Alright, so let's now try to have a bit more fun with buffers. Let's try to allocate a huge buffer and see what happens. Alright, so what I'm going to do now is that I'm going to run a virtual machine on top of my machine. So I have this application called Parallels. Now you don't have to do this, just watch me do it. And here I have this Ubuntu virtual machine, and I have allocated 2 of my CPU cores to it and 2 GB of memory to this virtual machine. I'm gonna go ahead and start this operating system, and I'm just gonna wait for it to start. And what I'm gonna do is that I'm just going to try to allocate a very big buffer here in my Ubuntu machine. Now, if you don't know what is a virtual machine, don't worry about it. It's just an operating system that I'm running on top of my own operating system, and I can just interact with it. So it's like as if I have now another computer, and these two are separated. Now this virtual machine right here, this Linux machine, is making use of my computer resources, but it is totally separated from my own machine. Now let's not get into the technical side of the virtual machines. Just think of this Linux machine that I have right now just like another laptop. So it's now like as if that I have gone ahead and I bought a laptop that has 2 GB of memory and 2 CPU cores, and now I'm running it. Okay, so that's basically what this is, all right? If you get started with deploying your applications, the server that you're going to get is probably something like this. So it's a Linux server that has 1 to 2 GB of memory, 1 to 2 CPU cores, and well, it's Linux and it's running as a virtual machine on another machine, okay? Anyway, so what I'm going to do is that I'm just going to open up the terminal right here, and here on the desktop I'm just going to create a file called maybe huge-allocation.js. Alright, you can go ahead and create the exact same file in that buffers folder that you have. And I'm just going to open this up in my code editor. So code huge-allocation. And I'm guessing that I'm not in my desktop right here. No, I'm not, but it doesn't matter. Anyway, so just go ahead and create a file called huge-allocation.js. And right here, what I'm trying to do is that I'm trying to allocate a very huge buffer and then monitor how my resources are being used. So I'm just going to first include the buffer object like this. Now here I don't have access to Prettier, so I'll try to take care of the spacing and formatting myself. So here I'm going to include the buffer object. And now I'm just going to create a new buffer and allocate a big buffer. So I'm just going to say buffer.alloc, and let's specify something big here. Now before I do this, let me just go ahead and open up the activity monitor here on Linux. It's actually called System Monitor, I guess. Yeah, System Monitor. So I'm just going to open this up. So here I can see all of my processes, and I can see how much resources, how much CPU, memory they are using. And if I go into the resources section, here you can see that in CPU, this is my first core, CPU 1, and this is my second core, CPU 2, and this is how much memory I have. This little area, this little purple area right here is how much of my memory is now filled. It's 1.4 gigabytes out of 1.9 gigabytes. And well, it's more than half full because, well, I have only allocated 2 gigabytes to this machine, which is pretty low. But for a server, it's pretty good, especially for small sized to medium sized applications. It could work just fine. So here in the buffer, let's try to allocate a buffer that's half of the amount of the memory that I have. So I have 2 gigabytes, so let's try to create a buffer with 1 gigabyte in size. So I'm just gonna do a quick Google search and search for 1 gigabyte 2 bytes. All right, so 1 gigabyte 2 byte is 1 times 10 to the power of 9. Okay, so I'm just gonna use this number. So here I'm just gonna put in 1E9, which again means 1 times 10 to the power of 9, which means that we're gonna have a 1 and then 9 zeros in front of it. So I'm just gonna write this down here, then 6 and then 9. So this equals to this many bytes, which is 1 gigabyte. So I'm gonna go ahead and allocate a buffer that is this big, which is really big, okay? If you don't have enough memory, please don't try to do this. Maybe go with something that's much smaller. Try to allocate maybe this much, all right? So in that case, it's going to be 100 megabytes and not 1 gigabyte. I don't want your machine to just crash while you're watching this video. So I'm just going to allocate this big buffer. Now what I'm going to do is that I'm going to go ahead and fill every single bit in this buffer. So I'm just going to, in a for loop, I'm going to say for let I equal 0, and then I less than b dot length. Now, in the buffers, if you run the dot length on a buffer, it's going to give you the length in bytes. So it's going to tell you how many bytes that buffer is. What is the size of that buffer? Okay, so that's what it means. If you run this, it's just going to tell you the size of the buffer, not how many bytes you have already filled, nothing like that. It's just going to give you the total length of the buffer, all the elements that it has, whether they're zeros or ones, or it just doesn't matter. The size of the buffer, whatever it is, this length is going to give you that in bytes. So here I'm going to say b.length is the size of the buffer in bytes. Okay, so now that I have the for loop, I'm just going to, for each element, I'm just going to assign something to it. Maybe 0x22. Doesn't matter, okay? So I'm just going to go ahead, create this buffer, and then put this one in all the elements of the buffer. And let's also do this in a set interval, because I don't want my node application to quit as soon as it runs, because we want it to be there, we want it to monitor it and see how much memory it's using. So here I'm just going to put a set interval function, and let's run it maybe every 5 seconds. And I'm just going to put this code, the for loop, here inside of the set interval function. So now all that we're doing is that we're just creating this huge buffer. We're allocating 1 GB of our memory to this node application, and then we're just writing this to each of the elements. So we're just filling every single byte with this value every 5 seconds. Okay, so let's go ahead and run this application. I'm just gonna maybe pull up the system monitor right here. I'm gonna make it full screen, and here somewhere there should be a search bar right here. So I'm just gonna search for node. Now here I'm seeing a few processes, but these are for Visual Studio Code. I'm not sure why it's showing them, maybe because Visual Studio Code is written in Node, but it doesn't matter. Now I'm gonna go ahead and run the Node application. So node huge-allocation.js. If I run it here, you can see the process. The memory usage right now is 5 megabytes. And well, we crashed. So I guess we did. Yeah, we just crashed. Okay, so you know what? Let's try it with something that's a bit smaller. Looks like that I can't allocate a buffer that's that big. So the operating system just crashed and it just exited after 5 seconds. So we saw that we did see the process appear for a second, but then after 5 seconds, when we tried to fill the whole buffer, it just crashed. And now the virtual machine application is telling me that your operating system crashed. You want to send us a report, but no thanks, this was intentional. Well, not really intentional, but well, it was because we tried to allocate a huge amount of buffer. So now I'm gonna go ahead, open up the terminal again pretty quick, and open up that huge allocation.js file and my system monitor as well. And this time around, let's go with half this amount. So I'm just going to copy paste this, and here I'm just going to go with 0.5 e to the power of 9, which means that it's now going to be this big, or 500 megabytes. Hopefully we're not going to crash this time. So here's the system monet. I'm going to search for node, and here I'm going to run the application. All right, so this is the code. Memory usage is now low, but after 5 seconds, all right, there we go. So now we can see that the memory usage for this application is now 500 megabytes, around 500 megabytes. And if I go into the resource section, we can see that now my memory is totally full. At 95% of my memory is now full. And well, it's because of this node application running in the background, and my operating system has allocated 500 megabytes, which is a very big size, to my node application. So I can see in my resource section here, actually for the resource of the memory usage of this node process, that it's using 500 megabytes. And if I try to go higher than this, my operating system will probably crash because, well, we can't allocate a buffer that's this big, right? Because I've got my memory used for other things. My operating system has its own uses of the memory. I've got a whole bunch of other processes running here. Well, it means if you have a system with maybe 2 gigabytes of RAM or 4 gigabytes of RAM, it doesn't mean that you can allocate a buffer that is that big, okay? It's a bit lower than that because you've got other stuff going on around. But the point of me showing you this whole thing is because I want you to get this feel that when you're creating a buffer, you are allocating a piece of your memory to the node application. And you can see that right here in the activity monitor. If you're on Windows, you can do the same thing. On Mac, the same thing. So you can just go ahead, open up the task manager, activity monitor, whatever the name is, and then allocate a big buffer. And here in the processes section, on your resource section, you can see that that process is now using that much memory. And that's exactly how much memory you allocate to that. And here you can also see that I'm getting so many bumps every few seconds here in my CPU usage. Now these bumps are because every 5 seconds we're trying to do this. And well, it's an operation that will take a while to complete. So we see these bumps in my CPU usage every 5 seconds. Now also, this is not the fastest way to fill your buffer. If you want to do something like this, there is this nice method called buffer.fill, and here you can specify the value. You can either specify a string, in that case it will run a character encoding on top, or a number. And here if you specify this, we can also specify some offset and end. Here this is exactly the same thing as here, but it's also much faster. So I can just say 0x22 and it will do the exact same thing. So it will now go ahead and fill all the elements of my buffer with this value. I can specify a hexadecimal, so just some binary data, or a decimal, or maybe a character, and I can also specify an offset and an end. So I can tell it to just go ahead and fill all the bytes, maybe from this position up until this position, with that value. So this is much faster than the for loop. This is more efficient. It's been optimized specifically for this purpose. It's been optimized in the JavaScript engine and Node just to be able to do this and fill buffers. I just did some benchmarking myself, and this fill method was usually 2 to 3 times faster than the for loop. Again, they're just doing the same exact thing, but again, this fill is much more efficient. If you don't know how to do benchmarking, we're gonna do it a lot in the stream section, so there you'll learn how to do benchmarking and stuff. But anyway, it's still the same concept. My memory usage will now be the same exact thing after, well, 5 seconds. So here's the node process, and you can see that the memory usage is that much. And I guess we could go a bit bigger than this, maybe how about 8? Let me just do it this way. So 8 and then times 10 to the power of 8 in this case. Now here it's 800 megabytes. So now let's try it with this. Let's see if we're gonna crash or not. So memory usage 100, where is it? Yeah, it's 800. It's not crashing. I mean, everything now works fine. Still the same amount. I guess maybe we could go just a bit higher, maybe 9. Now also, here you can see that my memory usage is now half full, and after that amount of seconds, after 5 seconds, it's now totally full, meaning that the node process will now kick in. Actually, not the node process, this line will kick in, and then my whole buffer, that whole memory that I have allocated, is now going to be filled. Okay. Now there's a maximum value that you can specify here by default, and you can take a look at that and something that this buffer file exports, and that's called constants. So you can go ahead and log something, which is, so console.log constant.max length. This is going to tell you how much of a buffer can you allocate by default. All right, you can change this value, of course, but by default it is 4 gigabytes. So if I run this, you can see that this value that I'm going to get, if you just put it in one of those calculators to convert it into gigabyte, this is 4 gigabytes. So the maximum amount of memory that you can allocate for your node process by default is 4 gigabytes. Now, you rarely need to do this, and again, in a lot of cases, the buffers that you're going to work with and create are kilobytes in size, sometimes megabytes. But it's also good to know that you can also do this so that you get a better feel about what happens when you create buffers. Again, you're just using your memory, and you have to be careful when you are using the resources of your machine. Okay, if you're not careful, you're gonna crash. I mean, as you saw right here, I tried to create a big buffer and my whole operating system just crashed. Not just my node process, my whole operating system. So it's really important to keep that in mind, that you just can't, be not careful with this one. You have to be real careful, because now you're using real resources from your operating system. So if you're not careful, your whole production server could just go down, and something that you don't want. Now here, let's just try it one more time, see if we can get it to crash. Now with the exact same thing, 1 GB. Now it looks like it didn't crash this time. I don't know why it crashed the previous time. Maybe my operating system was using a huge amount of memory itself, so it didn't allow me to do that, and it just became confused and just crashed. So one thing that's for sure, if I try to now allocate something more than 2 GB, because I don't have more than 2 GB of capacity in this operating system, now this will for sure crash no matter how much resources other processes are using. So as soon as I run this, my operating system should crash after 5 seconds. So let's just run it and monitor this. So here's the node process. Memory usage right now is around 5 MB. It's now 600. 1 GB. It's now struggling a little bit to get to that 2 GB. We're not crashing yet. 1.4. It's really trying to push to the limit how much memory you can now use, but we should now crash anytime. So let's monitor this. In the resource section, you can see that my memory pressure is all the way at the top, 99%. It's just trying to push to the limit what it can do, but it should crash right now. Let's see. It went down a little bit. It's kind of weird. Well, not weird. Well, Node is trying to automatically see what it can do and what it can't do, and just to manage resources by itself. But I'm trying to allocate this much, so I'm trying to allocate 2 GB. You can see that it's really struggling. It goes to 1.4 and then 1.3. We could crash. This is for sure not recommended. You shouldn't really do this, because as you can see here in my resources, my memory is now really, its usage is really high. And let's try to do maybe one Google search and see what will happen. Yeah, my computer is now frozen, super sluggish. Yeah, okay, so we crashed. So this is really definitely not a good idea to allocate buffers that are that big. And hopefully now you understand how buffers work, that you are now dealing with real resources from your hardware, and you have to be careful about how you're dealing with that. Alright, so hopefully now you have a much better understanding about buffers, and there's just one more thing that we have to talk about, and I'll see you in the next video.